Assalamualaikum warahmatullahi wabarakatuh. My name is Adrian Anshari and my name is 125060300111030. For this time, I want to review my TED journal with a title is an introduction of 3GPP long-term evolution LTE and LTE advanced. I want to review with 5 sub. Number 1 is history of 3GPP LTE. Number 2 is basic concept of LTE. Number 3 is introduction of LTE protocol. Number 4 is compare with LTE and LTE advanced. Number 5 is my conclusion of my review. What is LTE? In November 2004, 3GPP began a project to define the long-term evolution or LTE of Universal Mobile Telecommunication System or UMTS cellular technology. In LTE, compared with 3G and 2G is a higher performance, backwards compatible, and wide application. Evolution of radio access technologies. This picture of evolution of communication system from 1G, 2G, 3G, 3.5G, and now 4G. The concept of LTE is employs orthogonal frequency division multiple access of or OFDMA for downlink data transmission and single carrier FDMA for uplink transmission. Multipath induced time delays result in inter-symbol interference or ISE. With like this, an equalizer and receiver against frequency selective fading cancel transfer function. Frequency selective fading. The coherence bandwidth of the channel is smaller than the bandwidth of the signal. Like in the picture, the bandwidth is transmitted single carrier signal with a multiple distortion. Received signal distorted by frequency selective fading, and that was effects was very many. It may be useless for increasing transmission power. This is a cyclic prefixes. For one is signal with varying delays combined at the receiver for N, and then the baseband processor strip off CP resulting in RSCP function in time domain. FDM versus OFDM. In FDM, conventional frequency division multiplex multi-carrier modulation technique is like this, and for OFDM or orthogonal frequency division multiplex multi-carrier modulation technique is like this. So the OFDM is saving more bandwidth than FDM. LTE downlink or OFDM is improved spectral efficiency, reduce ISI effect by multipath, and against frequency selective fading. This is like the picture of EFDM with 1 subcarrier and 6 subcarriers. LTE uplink or ST-FDMA. ST-FDMA is a new single carrier multiple access technique which has similar structure and performance to OFDMA. This is the symbol of occupy 15 kHz for one OFDMA symbol variant. With FDMA data symbol occupy with many OFDMA cross 15 kHz for one defined NC-FDMA symbol variants. This is a multi-antenna techniques with diversity for improved system performance, beamforming for improved coverage, less cell to cover a given area, SDMA for improved capacity, more user per cell, multi-layer transmission or MIMO for higher data rates in given bandwidth. Generics frame structure allocation of physical resource block or PRBs is handled by a scheduling function at the 3GBP base station or inode B. This is a frame structure from frame 0 and frame 5. This is always link. Resource grid. One framing is 10 milliseconds or 10 subframes. One subframe is 1 millisecond. On 2 slot. One slot is 0.5 millisecond in an resource block. One resource block is 0.5 millisecond and contains 12 subcarriers from each OFDM symbol. This is OFDM or SD-FDMA symbol type. LTE spectrum bandwidth and duplex flexibility. This is the picture of LTE spectrum. This is a paired spectrum and reduced paired spectrum, and then a reduced UE complexity and unpaired spectrum. These are LTE downlink channels. This is LTE uplink channels. LTE released 8K features high spatial efficiency on FDMA in downlink and single carrier FDMA in uplink. Number 2 is very low latency, short setup time and short transfer delay, and short handover latency and interruption time. Number 3 is support of variable bandwidth 1.4, 3, 5, 10, 15, and 20 MHz. And number 6, compatibility and interworking with earlier 3GBP release. Number 7, FDD and TDD within a single radio access technology. Number 8, efficiency multicast or broadcast. Evolution of LTE advantage. Number 1 is asymmetric transmission bandwidth. Number 2 is layered OFDMA. Number 3 is advanced multi-cell transmission or reception techniques. Number 4, intense multi-antenna transmission technique. Number 5, support of large bandwidth in LTE advantage. Asymmetric transmission bandwidth. Symmetric transmission, voice transmission, UE to UE. Asymmetric transmission is streaming video the server to the UE on link. This is a picture of symmetric bandwidth in or and asymmetric bandwidth. The LTE download bandwidth on symmetric bandwidth is 20 MHz, and for LTE upload downlink on symmetric bandwidth is 20 MHz. So the downlink and uplink on symmetric bandwidth is the same. It's 20 MHz. And then in asymmetric bandwidth, LTE advanced download link bandwidth is 20 MHz. Same for like symmetric bandwidth, and the upload LTE advanced uplink bandwidth is just 10 MHz. So this is lower than symmetric bandwidth, the uplink. And then layered OFDMA, the bandwidth of basic frequency block is 15 until 20 MHz. Layered OFDMA radio access came in LTE Advanced will have layered transmission bandwidth, support of layered environments, and control signal formats. Advanced multi-cell transmission or reception techniques. In LTE, the advanced multi-cell transmission or reception process helps in increasing frequency efficiency and cell edge user throughput. This is a advanced multi-cell. The advantage is estimation unit, calculation unit, determination unit, and feedback unit. Intense multi-antenna transmission dynamic. In LTE Advanced, the MIMO scheme has to be further improved in area of circle efficiency. Avoid the cell truth into cell edge performance. In LTE A8 Advanced, the antenna configures of 8x8 in downlink and 4.4 in upload are plane. In this technique to extend the coverage area, remote radio recruitment or RREs using optical fiber should be used in LTE Advanced as effective technique to extend cell coverage. This is a RRE using optical fibers. Support of larger bandwidth in LTE Advanced. Peak data rates up to 1 gigabit per second are expected from bandwidth of 1000 MHz. FDM adds additional superior to increase bandwidth. This is the bandwidth of LTE, just 20 MHz. This is a compare between LTE and LTE Advanced. Number 1 is peak data rate downlink. On LTE, the downlink is 150 megabit per second. But in LTE, it was a higher downlink. The downlink is 1 gigabit per second. And then number 2 is peak data uplink. On LTE, it's just 75 megabit per second, and on the LTE it was higher, is 500 megabit per second. The transmission bandwidth from the link for LTE is 20 MHz, and for LTE A or LTE Advanced is 100 MHz. Transmission bandwidth uplink is 20 MHz for LTE and 40 MHz from LTE-A, but it remains as defined by ITU, International Telecommunication Union. And the mobility for LTE is optimized for low speed, high performance at speed up to 120 km per hour, and maintain links at speed to 350 km per hour. For LTE-A, it's the same for LTE for mobility. For coverage, full performance up to 5 km, it's just for LTE. But for LTE-A, it's same coverage, but should be optimized by development in local areas microcell environment. In capable bandwidth for LTE is 1.350 and 20 MHz, but for LTE-A is up to 20 until 100 MHz. Capacity for 200 active user per cell is in 5 MHz is for LTE, but on LTE-A 3 times higher than that in LTE. So my conclusion is LTE-A or LTE Advanced help in integrating the existing networks, new network services, and terminal to suit the escalating user demands. LTE Advanced will be standardized in the 3GBP specification release time, LTE-A, and will be designed to meet the 4G requirement as defined by ITU. This is my reference for my review. I picked up from 10 journal on IEEE. This is my Channel. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.